I'm Simon. I work at Holiday Check. I'm a front-end engineer, but I focus more on JavaScript and Node.js currently, so not so much the CSS stuff. Yeah, I'm talking about JavaScript, and to me and to many other people, JavaScript is key. So there are reasons for it. There's one that got really popular recently. So this guy didn't actually say this first, but it has something to do with rules and power. But it's the rule of least power, and this is actually a manifest that is in the W3C website, and it says basically that you choose the tool that's the easiest for the job. So they can do everything, but in the easiest way. That's my free translation. And one guy, JS.everywhere, he said this. I'm not sure which way it was, if the rule was there first or he said this sentence first, but he was saying this. So he was saying any application that can be written in JavaScript will eventually be written in JavaScript. And I think that's true for a very good reason, because we have JavaScript in the browser, so we basically don't have a choice. In the browser only speaks JavaScript, so you have to do JavaScript. And the obvious question to me was, if I have to use JavaScript in the browser, can I use it on the server too? Because there's one big problem with JavaScript, that's SEO. I'm not sure in what companies you work, but I'm working at Holiday Check, and SEO is pretty important to us. So if it would be a completely client-side application, we'll probably have difficulties to be indexed by Google. So this is the first thing when we say JavaScript or no, we are not going to be indexed. So what's the solution? I said this before. I was thinking about Node.js, and I was thinking about sharing code. So can I use the same application that I run on the client and run it on the server? This was my initial question. And back in the day, I thought, oh well, just take this code, put it into Node.js, it will work. So this is what happened. This was my first steps with Node.js, and then it went really bad. Yeah, so what are the issues? Any ideas what the issues are? So there's one. To me, that's the biggest one, but that's not so obvious. When you're on the client side, you can put stuff into the DOM all the time during runtime. Doesn't matter, it's asynchronous. But the server has only one chance to answer. So you send a request to the server, it has to collect all HTML and answer in one big chunk of HTML. That's different to the client, so you need some indicator to say, I ran all the code, I'm done, so we can send the response. This is pretty easily solvable, but it's obviously a performance issue. And it makes the code a little messy, because you have to say at some point, you have to call the callback. I come to that back later. So the second thing is browser APIs, which you don't have on the server. You don't need all of them. Most will want the DOM on the server. I will say something about the DOM later. The other one is the XHR. For example, if you're doing a request to a service, you need something on Node.js too. Node.js obviously has something, it's the HTTP module, but it doesn't quite have the same API. In fact, it's totally different. And the third one is the history API, but this basically stands for routing. So you have to have something on Node.js that does what the history API does for the browser. So to give you a quick update, I was talking about sharing code between the browser and the server, run the same code I'm running in the browser on the server side, and I'm now talking about the problems, and those are one of them. This what happened when I tried to run my application to Node.js without thinking about it.
Now you've seen everything.
Yeah, funny story. So, but let's go on. The browser APIs, what do we have in this to the API. We just need something that can do the routing on the client and the routing on the server. And the best thing would be if it has the same API, so we can actually share code. So, any idea what this is?
Turtles.
It's a turtle, yes. And turtles are very slow. And there's something else that's very slow, and that's the server-side DOM. In fact, the DOM is slow anyway, doesn't matter on which side. But on the server it's even slower. So to give you an idea, what I mean with slow is if you made a test at holiday check and put 5,000 a chunk of HTML of 5,000 elements into the DOM, and it took the Node.js roughly 200 milliseconds. So this doesn't sound like much, but it is a lot. 200 milliseconds just for rendering is a lot, especially if you consider that 100 milliseconds feels instant to the user. So you already lost the battle if you do this on the server. So since you have a choice on the server, in the browser you don't have a choice, you have to use the DOM, but on the server you have the choice. If you don't want to, if you have the possibility, don't do it on the server. If you want to do it, those are some alternatives. Yeah, you can just have to. I'm not going to talk about this. Well, so how can we achieve this? When we have this performance in mind, how can we achieve that we have the same code on the server and on the client? You have to abstract the APIs. So to the app, every API is the same, and the framework does the hard stuff for you. So it abstracts it away. That means you have to do a contract basically between the app and your framework and decide what API to use. In order to do that, you need to design a framework. And this could be a framework design. That's what we do at Holiday Check. So we have a framework core, which to the app, that's a black box. You never actually talk to the framework core. And then you can register modules on the framework. So imagine this, you're willing to implement a module, then you ask the core to give you a sandbox. Sandbox is something like a playground for a module, and it gives you all the APIs you need. So the core answers, it injects the sandbox into your module, and then you can use it. Is that clear to everybody, or do you have any questions to that? And you can have lots of modules in one app, just have to run them separately to separate your concerns, basically. So this is how core could look in code. This function would be the function that asks the core framework to give you the sandbox. You need something to register templates. That will be more clear when I show it in the demo. And you need something to run. On the server, that would be start the server. On the client, that would just be start the routing. Something to start the history, basically. Okay, and that's how the sandbox looks. So I decided to have a sandbox which has several namespaces. We talked about the different APIs. So the router, for example, is what I was talking. What I was meaning is the API. So in the router, you will later find the function to register routes and route them to some callback. And the second one is templates. That's obvious. You can use this to render templates. I used handlebars in the example. And the last one is HTTP. That's used to do service requests. And that's how an app could look. So this is one app with one module. You could have several here, as I said. You just add a module to the framework answers with a sandbox. And it does this like this. You give the framework a callback, and this callback expects that the framework injects the sandbox, and then you can use the sandbox inside the closure. So what are the differences that make the app use the same APIs regardless of the environment? So in the core, that's obviously just a different sandbox. You can decide if you want to have the sandbox in the framework. It's a different implementation in the framework, and the sandbox is just an interface. In this case, I just did two completely separate sandboxes, one for the server and one for the browser, to make it easier. So then you have registered your module. We call this module function, and then you then declare what's this function. Second difference is the templates. There are many ways to do this. I decided to register a templates folder on the server, so the server can register all the templates, load them, compile them, whatever. And the browser doesn't actually have an implementation for that because it doesn't register the templates again. It will ask for the templates for the server, so I just make an easy assumption that the templates that are put into the render function is the name that I can find in the templates folder. Run. I always have this. Here you start the server, and here you start the routing. I use page.js because in this case it's very easy. It's the exact same API as, for example, Express.js. It's a framework you can use in Node.js to do routing using Node.js. If you want to hear more about Express.js, you can ask me afterwards, but I don't want to focus on this. So this is the more important stuff, because the server or the stuff that the module you only set up once, and from that point on you focus on your module. So this is the more important stuff. That's the sandbox. So the first namespace I showed you was the router, and the router has pretty similar to what Express.js does, the get function. You can have several more, but in this case I just want to ask the one service for get requests. So I only implemented the get. You can have post and put whatever you want. So if you call this function, you can register a route, which is a pattern. It's a pattern like /name, and then you can give a placeholder for an ID that will be automatically passed. I showed this later before. And then the client, I use page again, which I previously started. You remember this? I started page, and before you start it, you have to register the roots of the client. So that's pretty similar. The second one is rendering. So on the server, I have a global in this case. It was the easiest way to implement it. It's just a demo framework, so it's not really finished. So I use a global HTML, and I put the template in there. So this one renders the template. I put some data in it to put it in a global, and this global is later used when I call the done callback to answer to the client. That's what I meant previously when I was saying the server needs to have some kind of indicator to know when it can answer to the client. So you have that on the server, and on the client, I do post requests. So I don't need to register the templates again or put them into some kind of bundle. So the easiest way was to ask the server for a specific template, make it render it, and then I just take the result that I get from the service, just like a template provider, and put it into my view. Okay, and that's the longest one, but not the most complex. I had to split it on two slides. That's the way you can do service requests. So on the server, you use the Node HTTP module. You get request. The main difference is to what jQuery, for example, does. That you have streams. So you have to listen to the data event, which can be executed several times, and then once it's done, the end event will be fired, and you can collect what you previously added to the data object. And on the client, I'm sure you all see this. I used jQuery just to make it mini short, so it fits on the slides, but you can obviously use everything. But I guess everybody has seen this. This is a usual jQuery GET request to URL. And this, by the way, is a pattern that was introduced with Node.js. It says, so the null is usually the error, and the second part is the data. So if you find something like this means you need to check the first parameter for being null to be sure that there was no error, because you have a problem in callbacks. They can introduce try catch, for example, because at the time of the execution the error is not being thrown, but later, so we have to give this error back somehow. So if the error is null, you can use the second parameter and assume it's the data. So what are the differences in the module itself? That's the cool thing. There are no modules, no differences. That's the whole point of the framework. So you can write the module in with the same syntax, and it works in both environments. So now I'll show you how this could look. So I prepared an app. I hope you can see it. So I have here the create message, which is then used by the client and the server initialization to inject the framework. I call it two-phase, so this is what I meant previously with this framework. Then you have the module function to register the module, and the framework uses this callback to inject the sandbox. And then we have the router, and I want to register a route that's called result, so I can use some localhost call /result and get to the page, and the page returns whatever I'm going to render. Before I do that, I want to have some data. This is the dummy service I created before. Here I'm checking the error, because I assume the first one is the error, it's the pattern I was talking about. And then I render the result with the data. So, and this is the very important part. I have to say done at some point to make sure the server knows I'm ready. It can send something back. Unfortunately, this is the only thing that's specific to the server that you have in the code, but don't need on the client. But anyway, it makes sense to have some kind of profiling of the client to see how long an app took to render or something like this. Maybe it's useful there too. So, and then I do another route to show you that I can switch on the client between pages without asking the server for the whole HTML again. This is just a simple index page. This is the Node.js module system. You don't need to worry about this too much, you just use it here to have different files. So, let me start this. I have to run the server. This does everything that I told you before. Just starts a server where the routes are registered. And so I will do this one. And see page. This is my template right here. The index. Go to result. It uses the root I previously registered. And it should go here to the result page, where it goes through all the results I get from my dummy service and lists all the results I have there. The dummy service looks like this. It's just simple HTML returning a list of items. So when I click on this, I should go to this page and see it. So this is not exciting at all. But what is exciting is I can show you first that it works without any JavaScript. So I see I disabled it. I still have the full HTML, so we are sure that Google is going to index us. And then show you another thing. We just quickly change the server here. So I register middleware on the same route to make sure I know when a server request happens. In Node.js, you always have to restart the server after you make changes. It's a sad thing, but they are automatic ways. So I changed it so every time it does a request to the server on this route, I should see something in the console right here. So I'm visiting my page again, the result page. I use the address bar, so I should see something here. Server request happened. So now I'm on the client. I have delivered all my code there. I know my templates. So I'm switching pages. I go back to home. But nothing is going to happen on the console here because I didn't add any middleware to this specific route. But when I go back, I shouldn't see any requests to the server. So we have one server request. I can even clear it. No, I can't. But you believe me, there's one server request. And if I go back to results, I should see the result here. But no server request. That's right. Why did this happen? Well, I can tell right now, I can check afterwards. It is supposed to work right here. Check again, maybe it didn't properly restart. Server request, I go back and force. Still. Yeah, I need to check this. I know why it's not.
JavaScript has to be enabled, right?
Maybe that's the point, yeah. But yeah. So I disable JavaScript, obviously it's not working. Okay, again, we see one server request, and I go to the home page. Nothing is happening. I go here. Nothing is happening. Thank you. So you see, we can have the advantage of server-side rendering, and when we know the client is able to do JavaScript, we let him overtake all the work.
So, quick question: how do you decide whether the client can do JavaScript when you render the page on server on the client?
So again,
how do you decide which version to serve, whether to serve the JavaScript code or the renderization on the server and send that?
I just pretend that every request that hits the server, so is done by using the address bar. It's going to be a user that doesn't do JavaScript. So I always answer with all the HTML and all the JavaScript codes. And then when I do the routing, that's the first point where I realize that the JavaScript isn't working. This works automatically because the history API doesn't actually do anything, so it goes through to the server. So I don't have to do anything actually to decide. It's a little overhead obviously for the clients that don't do JavaScript because of the JavaScript code, but I think that's the small trade-off. Okay, so back to the talk. Any question to the implementation so far? Okay, go back to the talk. So a quick recap what we achieved. The first thing is a pretty small one, I have to admit. Usually you don't do JavaScript for users that don't actually use JavaScript, but this might be a point for some. I think the percentage is below 1% of users on the web right now that don't have any JavaScript enabled, or a browser that isn't even able of interpreting it. The second one is speed, because usually what you do when you have a full client-side application, you ask the server for the same page all the time, regardless of the route you're using. So you get all the code all the time, and then the client renders the page eventually. So in this case, you're able to do this on the server. So you know you're on an index page, so I can deliver the index page, the rendered index page, or the HTML to the client. This makes it a little faster for the user, and it also gives us cacheability. So we can cache every response in the CDN, because it is not the same for every user. And it's the same for every user, not the same for every route. So we can cache the HTML2 in the CDN, which makes it even faster. And the last one obviously is SEO. It depends if it's a concern for you. This was the main concern for us, but I think the other three are pretty good benefits to use this technique too, even if you're not depending on Google or other search engines. But thank you, that's all I wanted to show you. If you're interested in how the framework works internally, not just how you write apps, it's on my GitHub. And the slides you can find there too. Thank you.
have you done performance measurements to see how long it actually takes you to render pages on the server?
Not with this one. We have our own implementation at Holiday Check where we use server-side DOM, and that is pretty slow. So if you use the DOM, it's pretty slow on the server. So as I said before, when you have 5,000 elements, it takes you 200 milliseconds. But usually, and you don't do that, your pages shouldn't have any this amount of elements on the page. So it's pretty fast if you don't do that. It depends. So what do you want to know especially?
I was just wondering what real life performance was like. I mean,
compared to others like PHP, for example.
For example,
yeah.
Or, you know.
So it's pretty fast if you just use a templating engine on the server. It's really fast then. But yeah, if you use the DOM, it is obviously slower than others like PHP.
So
but yeah,
most users would be rendering on the client, right? So that wouldn't be such a huge problem.
Exactly, and the idea is that you can cache all the pages in the CDN. So the Node.js is more like a generator of pages, and you put it in the CDN rather caching layer. So the Node.js, once the caches are warm, shouldn't be hit so often anymore. Anymore? Okay, thank you.